this actually looks like a picture where I grew up. I grew up in eastern Wyoming, and there on the, on the hills and valleys, there'd always be these old cars laying around, and I wish I had captured some of those to fix them up, because when I was a little younger than you guys are, a lot of them were in fairly decent shape. But let's just say we're working here with a stoichiometry problem, and I realize that stoichiometry, we usually think of being chemistry, but here we're going to talk about car bodies. And if we had a chemical reaction or a car body reaction that said this, that if you have a car body and you're going to add tires to it so that you end up having a car, does that make sense? What's the ratio of tires to car bodies? So a 4-to-1 ratio. And so that gives us one. What we really come down to is this, that a car consists of BT4. Does that make sense? So that looks a little bit more like a chemical reaction. And so here is the question for you to consider, and I think you're going to say, oh, that has a pretty simple answer. If I have 18 car bodies and 43 tires, what's the largest number of cars that I can build? And so you see that this really comes down to a stoichiometry problem. So I'm going to go on to the next slide here, and I need to switch to, okay, on to the next slide. So here on the next slide, I'm going to change to a color just to make sure this, hopefully this is the easiest color to see. So that we had, help me make sure I get the equation right, that I have a body of a car plus 4 tires equals BT4, which we're calling the equation for our car. And we said that we have 18 car bodies and 43 tires, and I'm guessing that you're going to be able just to look at this and see how many cars we could make. How many cars is it? 10.75, right? Or 10, because we probably can't make 0.75 cars. So we come out to something like 10 cars that we can make. But let's think about how that would look if we were actually going to write this down. What we'll notice here is that our ratio of bodies to tires that we need is a ratio of 1-to-4. That's what we need. Now, what is our actual ratio that we have? The ratio that we actually have of bodies to tires is a ratio of 18-to-43. So, what is 18 divided by 43? You guys have all my calculators out there, almost. So I get out my calculator, I do 18 divided by 43, and I get a ratio of, instead of up here, I had a ratio of 0.25. Down here, I have a ratio of 0.42. So what that really tells me is that I have a lot more car bodies than I need. Do you see why? The number that's on top here is big enough that it's giving me a bigger number, a bigger ratio than what I would expect. So I really can't make anywhere close to 18 cars. I'm going to be limited by this other thing. Now there's a couple other ways of looking at this problem called limiting reactants. And so that's one way to look at it. Let me show you a second way to look at that. We're going to pull out my eraser and erase all of this stuff down here. And we're going to do this exactly like the stoichiometry problems, kind of like the stoichiometry problems we've been working, in that we have 18 bodies and 43 tires, and we have a question mark under how many cars can we make. Now if I do this stoichiometry and I say I have 18 bodies of cars, and I know that when I get this made, I'm going to get one car for every one car, BT4, for every one body, so that my bodies cancel out. So if I had all the tires in the world that I needed, if I had an unlimited number of tires, this would be the formula I could use to tell me how many cars I could make. And I'd end up with 18 BT4s, 18 cars. Does that make sense? But that's assuming I have an unlimited number of tires. Now let's look at starting with the tire calculation. I know that I have 43 tires, but the ratio of cars that I can make, BT4, I get one car for every how many tires? For every 4 tires. So notice here my units cancel out, and I come out with BT4. But what's the answer? 43 divided by 4. 43 divided by 4 is equal to 10.75. So I can only make 10 cars. So here I have a situation where I have started with a certain amount of each reactant, but I can't tell how much product I'm going to produce until I have done some stoichiometry and decide which one of these is going to limit how much I can make. Well, you can look at that and tell me which one is going to limit how many cars I can make. Which one is going to limit how many cars I can make? The tires. And so I'm actually limited to 10 cars because the tires are my limiting reactant. So we're going to get some stoichiometry problems that we look at that have the same kind of... We're limited to how many cars we can make by how many tires we started with. So that's one kind of problem we're going to be coming up to. We're also going to be coming up to something called, see it right here, percent yield. And percent yield is really easy to calculate. You do it on your tests all the time. If you take a test in a class and you get 40 out of 50, what was your percent yield? You just call it your percent correct. 40 out of 50, what's your percent correct? 80%. So you already know how to do this. So it's really pretty easy. You've expected to make 10 cars, but you only make 9. So you take your actual yield. 9 cars is your actual yield. Actual. Did I get it spelled right this time? Your actual yield is 9 cars. Your theoretical that we just looked at, that's theoretical, there we go. The theoretical yield, that's what we looked at in the last slide. That's how much you could make theoretically. We said that was 10. Now, of course, to turn that into a percentage, you have to multiply by 100, right? So we're going to multiply by 100, and we get 90%. You're not going to have any difficulty calculating percent yield, are you? So that's all there is to limiting reactant and percent yield. We'll probably work through some problems that have a little bit more difficulty.